Alright, so in question number 3, this is actually now slightly different. So being told to evaluate the integral of cos to the power 5 3xt x. So now this also looks scary for some, but this is also an easy one. So what do we do in this case? So you know at cos 5 to the power 3x, so we need to just make sure that there are some even powers involved as we calculate this. So what we're going to do is you can see that this can actually be represented as the integral of cos 3x times cos to the power 4 3xt x. But now you also know that this side here can also be represented as the square of a square. So it's actually the same as cos squared 3x, and then we have the square on the outside. So that's basically the same thing. Then we can actually see that this cos squared 3x can actually be represented as 1 minus sine squared 3x. And then now we can see that there's a value inside sine 3x that should actually help us eliminate this cos 3x. So we're going to let u to be equal to 3 sine 3x, du dx should actually be equal to 3 cos 3x, and then if we make dx subject, dx should actually be equal to du over 3 cos 3x. So put that back in and you can actually see that clearly now this will actually be eliminated, and then we'll be left with we'll have this a third because we have this 3 here, so we can pull out a third, and then what we'll be left with is 1 minus u squared, and then the bracket squared. So when you open this square of the bracket, we'll have 1 minus 2u squared plus u to the power 4 du. So now that will become, so when you integrate that, for 1 we'll have u, and then for this we'll actually have 2 over 3u cubed, then for this we'll actually have 1 over 5u to the power 5. But remember that u is actually equal to sine x. So that's what you have to remember. Then multiply the third back in after substituting forever there is a u, put sine 3x. So we'll have a third sine 3x minus 2 over 9 sine cubed 3x plus 1 over 15 sine to the power 5 3x plus c. And it's as simple as that.